Alright, okay. So now saya akan cuba try to demonstrate how we can analyze data in spatial epidemiology. So this is a dengue data, okay, dengue data for Kelantan, and dengue data in the year 2019, tahun lepas 2019. So this data comes from this data come from, okay, number one, first, the motivation of doing this. Okay, the motivation of doing this. Okay, remember in 2019 and there was a spike. There was spikes of dengue cases. I think at the end of 2019 lah, banyak cases of dengue kan, if you can remember. So because of that, we try to look at really or not there have been spikes or increased a number of dengue cases at the end of 2019. So what I have that at that time is that, number one, I've got dengue data for dengue cases, okay, in CSV format. We got columns of patients too, row 1, row 2, row 3, row 4, and then we have age, sex, occupation, income, and what type of tests that were done for them, okay, to test for dengue, right? So, and then in addition to that, we have two more columns. One is lat and one is long, latitude and longitude. Okay, so these locations are basically the locations for the residence of the patient. That's another thing though. If you take the locations of the residence, so if the infection happened dekat workplace kan, it is not accurate, right? Because kita ambil locations of the residential area kan. So I've got that data, and then if I got the data, I can only make points, okay, and then I can see the distributions of dengue data, ... But I need a base map. So because of that, I have to find another data. So what I did was, luckily at that time I got data from DOSM, Department of Statistics Malaysia. It is a spatial data based on 2010 census data. So they have polygons data. The one that I have tadi is CSV, is the point data, and then I have another data from Department of Statistics, polygon data, and polygon data for state and also daerah. Okay.
Oh, even specific lah. So memang boleh plot lah.
Yes. So I've got to have two lah. If not, I can only make point. So I need to have base map too. I need to have the base map. So I use R. So I call library SF, tidyverse, and then the polygons, the map of Malaysia that was provided by DOSM is named like this lah, Malaysia Mukim 2010. Okay, Malaysia Mukim 2010, and it is a shape file, a default format for ArcGIS lah, ArcGIS. So you got a few files tu kan, CPG, PRJ, SBN, shapefile, and other thing, including this PRJ. Quite a number of people miss this very important PRJ file. The PRJ file, that is the file that contain the coordinate reference system for the data. If you don't have this one, you don't know what projection or coordinate reference system for the spatial data. So I know that based on this, I know that Malaysia is using the RSO Malaya Meter Project coordinate system. Okay. Then I read data, and again masa ni when I read data, it read as X and Y. It was read as X and Y. So because of that, I tell R kan, okay, R, I want to let you know that the coordinate reference system for Malaysia is 3168. 3168 is the coordinate reference system for Malaysia. Alright, you can go to spatial reference
reference system.
EPSG, okay, EPSG, spatial reference org, and so this is the and then you can search for Malaysia. Kelantan is a Kelantan EPSG is Malaysia 3376, right? 3376 or 3375, yeah, almost the same lah. Okay, the one that I use is what? 3168. Okay, this is GDM. Because this is GDM. 3168. This is Kertau. Okay, this is Kertau. Just now, this is based on GDM. This is a new punya format lah for spatial data in Malaysia lah, yang apa ni, yang Jabatan Ukur dan Pemetaan is encouraging people to use. So that's another reason why it is quite pening lah, baffling lah when we use when we handle spatial data, because of so many coordinate reference system. Okay, but doesn't matter. Okay, so I set the coordinate reference system for Malaysia 3168, which tells R that okay, this is Kertau RSO Malaya meter. Okay, and then I this is polygon. This is polygon data, and when I map this, this is what map? This is choropleth map. Okay, choropleth map. So this is Bacok and Gua Musang. The whole thing Gua Musang besar kan, Gua Musang kan. And then these three 1 to 3 for Gua Musang. This is Mukim. Okay, Mukim. This is 3 Mukim. Okay. Alright. And then this is where I use ggplot and then Geom SF, and then I fill Mukim, and then it shows Mukim. This one I use fill daerah, and then it just show daerah. Okay, right. And then this is because in the data set tu ada juga jumlah penduduk untuk setiap for each of the polygons tu. Then I can also plot the plots, the choropleth based on the density of the population. If you look here, this is I think Kota Baru lah ya, Kota Baru. Tapi ada satu kat sini kan, I think this is very dense. This is I think dekat Wakache if I'm not mistaken here ni. No, lots of people here. Okay, lots of people here. And then at the same time I got dengue data. Okay, dengue data from vector KB. And I need to read guna function read underscore XLSX because this data come in Excel format. I also need to use name repair because dia punya variable name kan is so long. so I need to use name repair to harmonize the variable name tu. Ada yang ni dot ni maksudnya ada space antara variable name tu. So it makes the variable name tu very dirty lah. And then the problem is that this data set kan, if you look at the latitude and longitude, it is 5.82, 5.79, 5.82, 102. So these are basically coordinates based on geographic coordinate reference system, WGS 1984. Okay, WGS 1984. Dia orang tak pakai RSO Malaya meter, even though they are using apa tu mesin tu mesin ambil locations tu. Tapi even though you can set that to RSO Malay meter, but they use WGS 1984. So when I read this, I need to tell apa ni, to tell R that okay, the coordinate for this data sets is longitude, latitude, and then the coordinate reference system is 4326, basically WGS 1984. So if you look here, WGS 1984. So now the problem now, I got two maps, one in Kertau, one in WGS. Kan, dua. If I overlay this one, it doesn't work. Dia akan lari, okay? And then I also did some exploratory data analysis, and I can see someone ada a few point dekat sini, ada kat sini, ada kat sini. So this is because ada data yang apa ni, tersilap. Ada yang lag jadi long jadi lag. Biasalah apa ni, that happens. Okay, that happens. Right. Now and then what I did now, okay, I missed to tell you this. Actually, I convert point data tadi from WGS 1984 to Kertau RSO. Okay, to Kertau RSO, and then by doing that, or only by doing that, then I can plot the points over the polygon. So this is the point data, and underneath it is the polygon data. So that's why you got geom SF here and geom SF here. If I use geom SF, then Kelantan okay, doesn't matter. Okay, so we have two maps here overlaying one another, right? So and you can see lots of cases happen in the apa ni, this area lah, because does it say that this area high risk for dengue, or it is because there's simply more people here? Okay, one question that you have to ask. Okay, you want to have one question you have to ask yourself, right? So okay, and then this is for lelaki and perempuan, almost the same. And then this is January, February, March, April, May, June, July. Until July. I've got data until July only, right? Okay, yeah, no problem. But you can see 1, 2, 3, 4, 5, 6. Okay, and then this is the time series data with epi week on the x-axis. So you can see data naik turun, and then of course in July tu memang apa ni, suddenly cases increase quite a lot lah, right? And then this is I did some animation just to show the distributions of dengue for each week. Okay, for each week. Okay, week 13, week 14, 15, 16, 18, 20, 22, 25, and then this is the cumulative of cases, right? Over that period lah. You can see case mula-mula start kita kan, and then makin banyak more cases. This is cumulative cases, cumulative cases. Yeah, so it seems like it starts from here and then it just like spread out. Okay, spread out. What else? And this is the incidence. Okay, this is the incidence. So how to do that? We have the number of population for example this one Beklam and Imbacok, and population for Gunung, Imbacok, Mahligat, Imbacok kan. So this is the number of dengue cases. What I did was simply just take this number and divide by jumlah penduduk. Okay, number of population. So then I divide by 1000. So this value will actually represent where is it? So this value, incidence 1000, basically represent the number of cases per 1000 population. Okay, so this is 1.3 per 1000, 1 per 1000, 0.1 per 1000, so on and so forth. And then so I plot this one. So now you have a different map. Okay, this one and mana tadi? Mana dia? Argentina. Lagi. Okay, tak apa. Okay, so never mind. Go here. So not that much difference, right? But you can see that this is area where you have quite a high incidence per 1000 population lah dekat sini. Actually these two areas are apa Pintu Geng and some other. Later the problem with this map is that if I put my cursor, it will not respond to the cursor, right? So I need to go back to data and tengok balik kan. So that's why below I use leaflet and also map view to make the map interactive. So this is I just choose Kota Baru and Bacho. I think Bacho is here and Kota Baru is here. There are two areas where strikingly high incidence per 1000 population for dengue. These two areas, okay? These two areas. The rest tu lebih kurang sama je, okay? So I use map view. So by using this, I can go and see which area. This area has 7.4 per 1000 population, okay? And this one is 5. The rest 3, 2, 2, 1, 0. Okay. 3, 3, 3, 3, 2, 3. Okay. And then 1. Okay. Right. So it seems that this area basically quite an higher risk for infection lah if you based on incident per 1000 population. And there's this one. This for Kota Baru and Bacho only. Okay, this is okay. I think this. Okay, this one. Okay, Kota Baru. Alamak tak keluar pula. Actually sepatutnya keluar Mukim kat
saya
sini.
Google yang dance tu Mukim Kota.
Ya,
Pintu Geng kat situ lah.
Pintu Geng dengan Kota kan.
Mukim Kota. Sebelah itu Mukim Lundang.
Ya, betul. Actually I can apa ni show the instead of Kota Baru, I can change this to Mukim kat sini. So but I forgot to do that. I'll change this to Mukim so that it will return Mukim rather than daerah. But yes, so you can see Kubang Kerian. This is 3. Mana 7 tadi ya? 3. Baru okay. I rasa kat sini kot I kena buat apa ni suruh Kelantan because I think dekat here. So this one, yeah, this one sini kan 7, 7 and then there's a 4. These two lah, right? Okay, so from this demonstration I show you how we can visualize the point pattern, the points data, and also the aggregated data. I did not do kernel density, kernel density estimate KDE, and I also did not do geostatistic for this one. Right, so yeah, I think that's all. Any questions?